Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. It's our third video on straight line graphs. Let's start with the key thing we learnt last time. If you can have a graph in the form y equals mx plus c, m some number, c some other number, can you remember what m and c told you about that straight line? Well, you have to remember that now, so make sure you go away and learn that. C is called the y-intercept. It tells you the value of y when x is 0, the value of y where the line crosses the y-axis. And also, m tells you the gradient of the line or the steepness of the line. So just to give you an example, suppose I had the line y is equal to, I don't know, 3x subtract 5. That's in that form where m is 3 and c is negative 5. What is that telling us? M being 3 is telling us that the line has gradient 3. As you go to the right by 1, you go up 3. And C is telling us the y-intercept, so the graph goes through the point 0, negative 5. When x is 0, y is negative 5. And this is going to be the key and crucial for us to draw these straight lines much quicker than having to draw a table of values each time. And let's start by doing that very thing. If you feel like you can do this, pause the video, go ahead and then check your answer. Otherwise, we'll go through together. Now, we always want to write the equation of the line in the form y equals mx plus c. We've got y equals x. In this form, that is really y is 1x, remember there's a hidden 1 there, plus nothing. So that's telling us that m is 1, that c is 0, the gradient is 1, and the graph goes through 0, 0. So let's mark 0, 0 first. Gradient 1 says as we go across 1, go up 1, across 1, go up 1, across 1, go up 1, across 1, go up 1. And you can see we have the straight line y equals x. To be fair, we should have known that anyway. That's an easy one. It's the straight line where the x and y coordinates are the same. Okay? But that was so fast for us. Let's do it here again. Let's write it in the correct form. Y is 1x, add 3. That's telling me that m is 1 and c is 3. So the gradient's 1 and the y-intercept, it goes through 0, 3. So let's start here. Go through 0, 3, 0 across and 3 up. Gradient 1, across 1, up 1, across 1, up 1, across 1, up 1, across 1, up 1. You get the picture. And there we go. We have drawn that straight line in a matter of seconds. Y equals x add 3 without a table of values. What about this one? Let's do the exact same thing as we always do now. Y is 1x take away 5. So therefore m is 1, c is negative 5. The gradient is 1 and the y-intercept is 0, negative 5. It goes through 0, negative 5. The gradient's 1. Go across 1, up 1, across 1, up 1, across 1, up 1, across 1, up 1, across 1, up 1. You get the picture. And there we go. There's that straight line for us, drawn in a matter of seconds without a table of values, and we are done. So this is y equals x take away 5. And it's really clear from looking at them, we should have known that the gradient of all of them would be the same. After all, you've got 1x in each of the cases, and it was only the y-intercept that was changing for us each time, and the y-intercept was given by these numbers here. Right, let's try another one. Pause the video and see if using the form y equals mx plus c you can draw those straight lines really quickly. Okay, I'm going to say this is y is 3x add nothing. Therefore I'm going to state that my m is 3 and my c is 0. So the gradient is 3 and it goes through 0, 0. Let's start at 0, 0. Gradient of 3 means if I go to the right by 1, I go up by 3. Right by 1, up by 3. Right by 1, up by 3. And there we go. As simple and as easy as that. There's the graph y equals 3x. Let's do this one. It's in the right form, so we can just state that m is 3 and we can state that c is 5. So the gradient is 3 and the y-intercept, it goes through 0, 5. So let's go to 0, 5, which is here. As I go across 1, I go up 3 because the gradient's 3, so across 1, up 3. Okay, so drawing our straight line there, we'd have something that looks like that. It should have the same gradient as y equals 3x, but it's the line y equals 3x add 5. Again, drawn within the matter of seconds. And the last one here, we can state that m is 3, so the gradient is 3 again, and c is negative 2. Gradient 3 goes through 0, negative 2. Start at 0, negative 2, which is here. Gradient of 3 means go across 1, up 3. Across 1, up 3. Across 1, up 3. And you get the picture. And it should look something like that when we join the dots with a ruler. And that was that line there, y equals 3x subtract 2. And they're all parallel because they all have the same gradient of 3, but they have different y-intercepts. Here 0, 0, here 0, 5, and here 0, negative 2. And we're done. Okay, try these ones yourself. So I'm going to write this in the form y is equal to negative 1x add nothing, so it's in the form y equals mx plus c. M is negative 1, c is equal to 0, so the y-intercept is 0, 0. Let's start at 0, 0. Gradient of negative 1 means as I go right 1, I go down 1, right 1, down 1, right 1, down 1. And you get the picture. Our straight line is looking something like that. And that's our line. Y is equal to negative x, drawn very quickly. Okay, what about this one? Well, here, if we write this in the correct form, this is going to be y is negative 1x take away 2. So m is negative 1 again, but here c is negative 2. So the gradient's negative 1, but the y-intercept is 0, negative 2. It goes through 0, negative 2, and as you go right 1, you go down 1, right 1, down 1, right 1, down 1, right 1, down 1. And again, we get our straight line there, like that. And that's the straight line, y is equal to negative x take away 2. And the last one, y is equal to 5 subtract x. Well, that's really y equals 5 subtract 1x. And I could think of this as y add negative 1x. So that I could swap the negative 1x and the 5 and rewrite it in the form mx plus c, like that. This statement is always equivalent to that statement. So m is negative 1, c is positive 5. The graph goes through the y-intercept 0, 5 and has gradient negative 1. So we go up to 0, 5. As I go to the right 1, I go down 1, right 1, down 1, right 1, down 1. You get the picture. Our straight line is looking nice and easy for us to draw, just like that. Okay? And that's y equals 5 subtract x. And the last one for us to try here, pause the video and see if you can draw these really quickly using y equals mx plus c form. Here I'm going to write this as y equals negative 3x plus nothing. M is negative 3, c is 0. Gradient's negative 3, it goes through the y-intercept 0, 0. Start at 0, 0, go across 1, down 3, across 1, down 3, across 1, down 3, like that. Join the dots, and as quick as a flash, we have drawn y equals negative 3x. Done. What about this one? Well, here we can state that m is negative 3 and c is negative 2. So the gradient's negative 3, it goes through the y-intercept 0, negative 2. So let's start at 0, negative 2 here, go across to the right 1 and I go down 3. Across to the right 1 and I go down 3. And you can see I've got myself my straight line there, which I'm just going to draw like that. And that's the line there, y equals negative 3x take away 2. Still got a gradient of negative 3 like the one before it, but has a y-intercept of 0, negative 2. And the last one here, we can rewrite this as negative 3x add 5. So m is negative 3 as it has been in the two cases above. C is 5. Gradient is negative 3. It goes through the y-intercept 0, 5. So let's go to 0, 5. I go right 1, I go down 3, and I'll end up here. Go right another 1 and I go down 3 and I'll end up here. And we've got 3 points to draw a line through, which we can draw like that and label up your straight line to finish with as y is equal to 5 subtract 3x. The negative 3x tells you it's got a gradient of negative 3. The 5 tells you it goes through 0, 5. And that's it for this video. Thanks for watching.